Today's video is all about fingerprints and fingerprinting. And as you can see, we have a lot of goals to accomplish during these notes. Once again, even more goals. All right. So as far as the historical development of fingerprinting is concerned, we can trace it back to the 3rd century BC in China, where they had documents showing fingerprints on them, thus indicating that during this time, at least in China, there was some knowledge that fingerprints were unique. I'm not saying that they had anywhere near the knowledge that we did today, but that fingerprints were unique to people. Moving forward quite a bit to ancient Babylon, dating back to around 1792 to 1750 BC, fingerprints were pressed into clay tablets to mark contracts. So essentially a fingerprint was considered the same as a signature. And you know that a signature today we consider kind of binding. So once again, an acknowledgement that a fingerprint was unique to you. Jumping forward again, the earliest written study in 1684 in Dr. Nehemiah's paper describing the patterns he saw on human hands under a microscope, including the presence of ridges. So once again, he wasn't really saying that fingerprints were unique. He was finding them interesting and literally just looking at people's hands under a microscope and noticing all the kind of lines and ridges that you've probably noticed on your own hands. Then in 1788, Johann Mayer noted that the arrangement of skin ridges is never duplicated in two persons. He was probably the first scientist to recognize this fact. I say probably because he is the first recorded person to recognize this fact. It is definitely possible someone figured it out before him, but he is the person who is recorded by history as being the one to be the first one to say fingerprints are unique to each person. Continuing our historical development of fingerprints, 9 fingerprint patterns were described in 1823 by Jan Evangelos Perkin. And then Sir William Herschel, that dashing gentleman on your screen right now, in 1856 began the collection of fingerprints and noted that they were not altered by age. Pretty interestingly, essentially he got people to volunteer to let him roll their fingerprints. And then as they got older, he continued to take their fingerprints and noticed that over time they remained the same. This was very impressive at the time because while we knew fingerprints were unique to people, we didn't know if they changed over time, and he showed that they did not. Then we have Alphonse Bertillon. And you might be thinking, as I describe him, why is he in the historical development of fingerprints? And it's because he thought fingerprinting was not going to be good. That using fingerprints to identify people, like all of these other people had been suggesting, was going to be too scientific and too difficult for the average person to be able to do. So thus, he created the Bertillon system, which I'm going to show you more about in a second, as a means of identifying people. So he was kind of in opposition to fingerprinting, which is how he ends up being a part of fingerprint history. And in 1883, he was able to use his system to identify a repeat offender, thus showing that his system worked, and it became the Bertillon system became the dominant system used in the prison systems for the identification of individuals. Now, this is some pictures of the Bertillon system. Essentially, the Bertillon system was that you took a ton of measurements of the human body. You measured someone's head width and length, and you measured their arm span and their height sitting down and their height standing up, and you can see all these little positions. So essentially, you would put a criminal in all of these positions and take those measurements, and Bertillon said no two people will have all of these measurements being the same. And his system became the one that was adopted because it's a lot easier to teach someone to use a ruler than it is to identify fingerprints. But then came the case of Will West. So a strange occurrence happened at the Leavenworth Penitentiary that kind of changed the Bertillon system forever. So a prisoner by the name of Will West was brought to Leavenworth Penitentiary for processing. Officials were alarmed because a man named William West had been incarcerated there at that same prison since 1901, and they assumed he had escaped and been returned. I do kind of like how they were like, guess we lost a prisoner and never noticed, and we're fine with that, but that's a different story, I guess. And the records confirmed it. They confirmed that this was that person. They did all the Bertillon measurements and said, yep, this is William West. The only problem is as they took this Will West back to what was, quote unquote, his cell, there sat William West, still there. And up at the top of your screen, you can see the picture of the two Mr. Wests, Will and William, and they look essentially like twins, thus showing that the Mr. West was in fact a different man. But the two resembled each other so closely that according to the Bertillon system, they were the same person. It was not until the two Wests, who denied any relation to each other. They claimed never to be related in any way, shape, or form, despite their near identical appearance, were fingerprinted, that we could clearly see that there were differences between them. Now, unfortunately, the two Mr. Wests have really been lost to time. So as far as a conclusion of confirming whether they were related or not, I don't really have one for you. Aside from this interesting occurrence, they were not famous for anything else, so they were not really kept track of after this incident. But this showed that the Bertillon system could not, in fact, tell people apart if they looked similar enough to each other, thus showing that fingerprinting was going to be the way of the future. So continuing with our historical development, in 1888, Sir Francis Galton and Sir Edmund Richard Henry developed the fingerprint classification system that is still in use in the United States. So the system we use is very old. In 1891, Juan Vuschek improved fingerprint collection. He began to note measurements on identification cards, as well as adding all 10 fingerprint impressions. He also invented a better way of collecting the impressions. Before him, they were not necessarily taking all 10 fingerprints. They were trying to guess like what finger they thought the fingerprint they were trying to look at came from and go from there. Also, before, it was just a variety of inks and stuff that were being used to collect fingerprints, and he kind of created a better ink for fingerprinting. And then beginning in 1896, Sir Henry, same one from number 8, with the help of two colleagues, created a system that divided fingerprints into groups, along with notations about individual characteristics, and all 10 fingerprints were imprinted on a card, which they cleverly named a 10 card, which is still basically in use today. So what is the layer of the skin that produces fingerprints? So the epidermal layer, which as we learned about in hair is the very top layer, is responsible for fingerprints is the papillary/basal layer. And you can see that that is the very bottom of the epidermal layer. So essentially that layer is the one that is the transition point between the epidermis and the dermis. So your fingerprints do not originate like as low as your hair does, but are still pretty deep underneath your skin. So what are fingerprints? All fingers, toes, feet, and palms are covered in small ridges. We name those ridges differently depending on where they are. We call them palmar when they're from your palms. We call them dactyl when they're from your fingers or your toes, and plantar when they are from your feet. These ridges are arranged in connected units called dermal or friction ridges. They're often called friction ridges because it's believed that our fingerprints do help us keep a grip on things. Natural secretions, so like your body producing oil and sweat, plus dirt on these surfaces leave behind an impression, which we call a print, on those objects with which we come in contact. So we do not physically leave a part of our finger behind when we leave fingerprints. We're just leaving the oil, the sweat, the dirt that we have on our hands behind. So how are fingerprints formed? An animal's external tissue, skin, consists of an inner dermis and an outer epidermis. Once again, the creation of fingerprints is occurring in that papillary basal layer that is at the very bottom of the epidermis. And this is where all new skin cells are produced. So not just for your fingerprints, but all over your body. Now your fingerprints actually begin forming at the start of about the 10th week of pregnancy. Around the 10th week of pregnancy, the basal layer grows faster than the other layers and creates these kind of little bulbed fingertips like you can see in the picture up at the top. However, as baby moves around inside mommy, these start to collapse, and they collapse, forming these very intricate shapes. This is why no two people have the same fingerprints, including twins, because no two people are going to move the exact same way at the exact same times while they are being grown inside mom. So that uniqueness in movement causes us each to have unique prints. Now, there are 3 general fingerprint distinctions. There's arch, that only about 5% of fingerprints have, whorl, which about 30% of fingerprints have, and loops, which about 65% of fingerprints have. So arches are our least common fingerprint type, and loops are our most common fingerprint type. Now, each of those can be subdivided down further, so let's take a look at that. So first we have loops. They are the most common type of fingerprint. There are 2 types of loops, a left loop and a right loop. A left loop, as you can see, is going to come in from the left and exit on the left. Meanwhile, a right loop comes in from the right and exits from the right, hence their name. And you just see that there's that little loop there. Next, we have arches. They are the simplest type of fingerprint, but also remember the least common. A plain arch just enters from one side, exits from one side. Nothing fancy occurring in the middle. Versus a tented arch, which is still going to enter from one side and exit from the other, but you're going to see this little spike or tent in the center of it, kind of making it look like a little Charlie Brown tent. So 2 types of arches as well. Then we have whorls, which there are also 2 types of whorls. Now, whorls have at least one ridge that makes a complete circle. So if you think about like a whirlpool is where the water is circling around, this is where the fingerprint is circling around. So you can have a plain whorl and a central pocket whorl. In order to tell which you have, it is more difficult than our other prints we've just talked about. The first thing you have to do is find your 2 deltas. Deltas are little triangles within the print. And you can see there's 1 delta here, see that little triangle, and 1 delta here. Similarly, we have 1 delta here and 1 delta here. You draw a line through the center of both of those deltas, and then you find that ridge that does do the farthest outside complete circle. If it goes over your line, it's a plain whorl. If it doesn't touch the line, it is a central pocket whorl. So central pocket whorls are essentially just smaller whorls. Now these 2 can be hard to tell apart, so make sure you're paying attention to the deltas and the circle. Now there are 2 other types of prints that we need to talk about. We have the double loop whorl. It's called a whorl because it does have the 2 deltas like we just talked about. However, it's really 2 loops kind of holding hands with each other. I think it looks like a yin-yang, but you can see you have this 1 loop coming in and you have this other loop coming in. So it's a double loop, 2 loops. And since it has the 2 deltas, we call it a whorl. And then last but not least is accidentals. Accidentals are prints that do not fit into any of the other print patterns that I have just shown you, any of the other 7 that we just talked about. So they can kind of be a mix of anything. Now, I do want to tell you, a lot of students, if they're having trouble identifying a print, their urge is to guess accidental. This is a horrible idea because as you're about to see, they're super uncommon. So don't guess accidental unless you're sure. So this is just putting them all together so you can kind of see the comparison of what they all look like. This does divide central pocket down into left pocket and right pocket. We're not going to worry about that. We would call both of those central pocket. But you can see how different they each look from each other. So fingerprint examiners look for the presence of a core. which is the central part of a whorl or loop, so the very inside, you can see the black arrow pointing to it right there, and deltas, which are the triangular regions I was just talking about. Since this is a loop, it only has one, and it's located right there. They can also perform a ridge count, which is where you draw a line from the core to the center of the delta, and you count every ridge that it goes over. Now, ridge counts are not going to be unique to each person. Two people could have the same ridge count, but it is a characteristic that can be used to tell fingerprints apart. So when we look at our basic patterns, we can actually divide them down further. Now, left and right loops are equally common. So just collectively, like I said before, they make up 65%. Now, arches, they only make up 5%, but if we divide that down, it's really 4% are plain arches and only 1% are tented arches. So tented arches are pretty uncommon. When it comes to whorls, 24% are plain whorls. So once again, that is going to be the most common type of whorl, with central pocket being 2% and double loop whorl being 4%. Then you remember I mentioned before that accidentals are actually really uncommon. They only account for 0.01% of fingerprints, so barely any. So if we only have these 8 patterns, fingerprints wouldn't be individual evidence because there's more than 8 people in the world. However, within these 8 patterns, there is what is called minutia, and they are within the ridges of each finger, and that is what makes fingerprints unique, are these minutia. So let's look at those. So these are minutia. You can see that we have, then these black lines are representing the ridges of the fingerprint. So we have an island, which is where you have your ridge. It splits apart and then it comes back together, kind of leaving this loop in the center. A dot is when you have just this little bit of ridge that's not connected to anything. It's just floating out there like a polka dot. A termination is when you have a ridge that ends. Crossover is where you have 2 ridges that crisscross each other. A snort ridge, I like to imagine that someone was trying to draw a line, then someone said something a little bit funny, so they snort laughed, swooped their pen down, and then kept going. We have a bridge, which is this little bit of ridge that connects to other ones. A bifurcation, which is where a ridge splits into 2 and keeps going. This is different than a spur, where the ridge starts to split but then ends very quickly. So that's why it's not a bifurcation, because it ended. In the bifurcation, those ones would keep going. So we use these minutia once we've identified the print pattern to look for the unique features in a fingerprint. So we have this print here. We can tell that this is a left loop, comes in and out from the left side. And as a fingerprint examiner, we would go through and start identifying all of these different minutia points. Now, ideally, we would identify 10 minutia points that within this fingerprint for analysis. 10 is kind of that magic number, but as you're about to see, we have moved away from that. So you'd analyze this print and look for the 10 different minutia points. Now, how is fingerprint analysis actually performed? So we perform fingerprint analysis using the ACE-V method, which stands for Analysis, Comparison, Evaluation, and Verification. So before this method, you just identified 10 minutia points, and when you found a print that matched, you said that it was good enough. But this method really takes into account the full set of skills of a forensic scientist and is really better for everyone involved and gets us more accurate results. So let's break down each part. First, we have analysis. This is when you have your fingerprint from your crime scene or wherever that needs to be analyzed. First thing you're going to look for is level 1 details, where you identify the type of fingerprint. Left loop, double loop whorl, that stuff we just talked about. You perform your ridge count, which we showed going from the core to the delta. You try and figure out the orientation of the print. Is the print upside down, laying on the side? What direction is it going? You may also note if there's any sort of large scars or something in the print. If you can only identify level 1 details, you are not going to be able to determine this to be individual evidence. It's going to stay as class evidence. Now, if you can move into the level 2 details, this is ridge characteristics and points. This is where we look for minutia points and small scars and identify those specific minutia points and small scars. If you can get to level 2, you have likely been able to individualize this piece of evidence and will be able to use it in court. However, if you have a really good print, you can also take it to level 3, which is ridge structure, where you look for pores, ridge width and shape, and other tiny details. Now, when you do your fingerprints in class, you are going to be able to look for level 3 details because they're going to be made under ideal conditions. But a lot of times the prints that we get for crime purposes are not made under ideal conditions, so we might not be able to get level 3. But you can still use a print if you've gotten it to level 2. So then we would move on to the comparison step. And this is where we search known prints for levels 1, 2, and 3 details. Now, by known prints, that could mean you already have some suspects, you get their fingerprints, and you check those known fingerprints from those suspects. However, if you do not have a good suspect, this could also mean using the automated fingerprint identification system called AFIS. And this is a database that all local agencies and states are supposed to put their fingerprints of their felons into and store them, so you can actually use the computer to search through known fingerprints from people, and it will give you results. Now, AFIS does not work like how you've seen it on TV. It is not just going to spit out one match and tell you this is the person your fingerprint matches. You are going to select your minutia points that you think are important, and it's going to send you back probably 10 different fingerprints that match the requirements that you gave them. Then it is up to a person to move on to E, evaluation, where a person, not a computer, is going to examine that unknown print, our print from our crime scene, and the known prints from our suspects or from AFIS side by side, and they're going to be looking for those same level 1, 2, and 3 details. But they are also going to look to see if there's any differences. Maybe there's minutia points that exist on that fingerprint that don't exist on our unknown fingerprint. So those differences can be just as important as the similarities. Now, hopefully by the end of evaluation, our fingerprint examiner thinks they have found a match. And if they have found a match, they're going to move on to the final step of the ACE-V method, which is verification. So all positive fingerprint identification opinions must be verified by a second qualified expert. We no longer just have one person say that something is a match. We need a second confirmation. Now, ideally, this second expert does not have any knowledge of the case, and you do not tell them what fingerprint you believe is a match. You give them your unknown print, you give them those 10 known prints that maybe the computer spit out to you, and you say, I think I found a match. I need you to verify. Because without such verification, identification has not been proven to the level required by science. No report should be made of an identification until a second qualified expert has made that verification independently of influence or pressure from any source. So hopefully that second expert comes back and says, yes, I also think fingerprint number 5 is a match, and you say, great, and you can move on. But if that second expert comes back and says, I don't think any of these are matches, or thinks that a different one is a match, we're kind of going to have to start the process all over again. Now, there are 3 types of fingerprints we can get at crime scenes. We have patent fingerprints, and these are visible prints transferred onto smooth surfaces by blood or other liquids. So something left in paint, blood, something that is two-dimensional but visible to the naked eye without us doing anything. Plastic prints are left in soft materials such as clay or wax. So these are 3-dimensional fingerprints that are left in something. So the important part of plastic is they are 3D. And then we have latent prints, and these are not visible but made so by dusting with powders or the use of chemicals. Latent prints are the most common type of print that we get at crime scenes because people usually don't know they've left fingerprints behind. So we are going to have to process them to make them visible. So how are we going to do that? Let's watch and see.
Hello, my name's Phil Gilhooly, and I'm one of the lecturers in forensic science at Liverpool John Moores University. My background is in operational police work. Until 2007, I was the officer in charge of the Fingerprint Bureau at Merseyside Police. People will have witnessed many times crime scene investigators at crime scenes examining articles for fingerprints using conventional methods such as an aluminium powder and a suitable fingerprint brush, in this case what we call a Zephyr brush. This is particularly useful for examining articles that obviously can't be removed from the scene. However, modern methods and new technology allow us to examine most articles at a crime scene, but obviously that means we have to remove them to the chemical laboratory, usually in the Fingerprint Bureau of a police force, and we have many chemical techniques now used to develop fingerprints on articles that we would never have examined before. I'm now going to demonstrate how a crime scene investigator would powder a mark on a window at a crime scene and hopefully develop some finger impressions on it, and how we remove those fingerprints in order to send them to the Fingerprint Bureau with the hope that they will identify them. The equipment I'm going to use for this demonstration is, as I mentioned before, a Zephyr brush. I also have some aluminium powder. I'm then going to lift the fingerprints that I develop onto suitable adhesive tape, which I'm then going to place onto a vinyl sheet. This sheet then will contain the fingerprints themselves, and they will then be forwarded to the Fingerprint Bureau in that format. One of the other vital pieces of equipment now when a crime scene investigator is powdering for fingerprints is that they should use a suitable mask. With the advantages in technology such as DNA examination, it's important that the crime scene investigator doesn't leave their DNA on an object which they're powdering. First of all, we load the brush with suitable powder. Knock any surplus powder off the brush. We then we start off at the top of the article we're examining. The reason we start at the top is we can then remove any excess powder when we get to the bottom. We then discover some finger impressions which have been left possibly by an offender going through this window. And up until now, these fingerprints have been termed latent. And all latent means is that it's hidden, and we need to disclose them using the powder. Another important part is that in the finger impressions we remove all the excess powder from the fingerprints, because we want to disclose as much ridge detail without any excess powder within the ridges. So there we have the finger impressions that have been developed. We then break off a piece of the sellotape, making sure that we don't leave our own fingerprints on the tape. We then template the tape so that we make sure that we get all the finger impressions. We put the tape on at the right angle to recover all the impressions. We then anchor the tape one side, being careful we have to ensure what we're trying to do is to lift all the impressions without getting any bubbles or creases in the tape. We then remove the tape, which you can now see contains the fingerprints that were on the window, but it also leaves the impressions on the window also. It's impossible to age when fingerprints are left at a crime scene. There's no scientific way of saying when or how long ago they were left. But an indication is when they lift readily like that, the fingerprints haven't dried out fully and they lift readily onto the tape. The tape is now going to be placed on the piece of rigid clear vinyl that we've prepared earlier. Again, we template it to make sure it goes onto the tape. And it's a reverse of putting it down. So again, what we want to do is end up with no bubbles on the vinyl. We then remove the pieces of tape, the excess tape. And now we're left with a piece of vinyl which shows the fingerprints that we've lifted off the window, hopefully left by the offender.
So that is the process of how we dust for fingerprints. Now, dusting for fingerprints is going to be the most common way we lift latent prints, and you will be practicing it in class, but it's not the only way we can lift latent prints. There are also non-powder collection methods. We have ninhydrin, which you'll also be practicing with in class, that is best used on paper. Objects dipped or sprayed with ninhydrin, and then you can wait 24 hours, and they create this kind of purple-blue print. You can use cyanoacrylate vapor. This is the active ingredient in super glue. This is good for household items like plastic, metal, glass, or skin. And you heat the super glue essentially to get the cyanoacrylate vapor to go into a tinted environment, and it creates a white fingerprint. Then we have silver nitrate, which is best on wood or styrofoam. And the object can be dipped or sprayed in silver nitrate, and it makes a black or reddish brown print under UV light. And last but not least, we have iodine fuming, which is best for paper, cardboard, and unpainted surfaces. This is also going to be in a vapor tent where you heat the iodine crystals. They go into their gas state through sublimation, and they're going to create a brownish print. Now, the issue with iodine fuming is that the print does fade very quickly, so it must be quickly photographed or sprayed with a starch solution to seal it in place. The other ones will stay pretty much indefinitely, but iodine does not stay forever. Now, as far as the future of fingerprinting, new scanning technologies and digitally identifying patterns may eliminate analytical mistakes. Fingerprinting today is still very much done by humans, even with APHIS. However, in the future, it may be done completely by computers. Trace elements of objects that have been touched are being studied to help with identification of individuals. We're calling this touch DNA right now, where we're trying to get DNA from the objects that people have touched. So instead of using their fingerprints, we're going to use that sweat, oil, and residue that they've left behind to identify them. Also, to help with identification, other physical features such as eyes and facial patterns are being studied, looking at the unique patterns within your eyes, or kind of going back to the Bertillon system of facial identification works as well. Now, I know some of you are wondering, is it only your fingers that leave prints? Nope. Your toes leave prints, your palms leave prints, even the bottom of your feet, and lips leave unique prints as well. And we can process all of those the same way that we collect fingerprints. However, there is no nationwide database for toes, palms, or lip prints, so you would have to collect those directly from suspects. Now, we're going to have a lot of fun over the next couple days working with fingerprints. I think you're really going to love it, so come to class ready to learn more.